Right now, a powerful and highly complex storm system is stretching across nearly all of Canada, from the Pacific coast of British Columbia to the Atlantic shores of Newfoundland, creating a multi-hazard weather situation that is both geographically vast and meteorologically intense. This is not a single impact event. Instead, it is a dynamic system producing different but equally dangerous conditions depending on the region. On this Tuesday, March 24, 2026, the overall pattern is being driven by a deep Pacific low-pressure system that has moved inland, interacting with cold Arctic air already in place across central and northern Canada. The result is a sharp contrast in conditions, ranging from destructive winds on the west coast to life-threatening cold in the north and full blizzard conditions in the east. Beginning on the west coast, British Columbia is experiencing the leading edge of this system, where the primary concern is not snow initially, but wind. Vancouver Island in particular is facing a significant wind event, with the strongest impacts concentrated across the northern and western sections. As the low-pressure system pushes inland, it is tightening the pressure gradient along the coast, generating powerful southeast winds that are reaching gusts of up to 120 kilometers per hour in exposed northern areas. These winds are strong enough to cause structural stress, bring down tree branches, and create dangerous flying debris. As the system evolves through the day, wind directions begin to shift, introducing westerly gusts that maintain the threat even after the initial peak. This is not just a short burst of wind. It is a prolonged event with the potential for widespread utility outages and hazardous outdoor conditions. Even slightly more sheltered regions, such as eastern Vancouver Island and parts of the Sunshine Coast, are still seeing gusts approaching 90 kilometers per hour, indicating how expansive the wind field associated with this system truly is. As the system pushes further inland, the story transitions rapidly from wind to winter weather across the interior of British Columbia. The Chilcotin region becomes a focal point for a dual hazard scenario, where both snowfall and wind combine to significantly reduce visibility and create dangerous travel conditions. Snowfall accumulations in the range of 10 to 20 centimeters may not seem extreme on their own, but when paired with gusting winds approaching 90 kilometers per hour, the result is blowing snow and near-zero visibility at times. This combination is particularly hazardous along key transportation corridors such as Highway 20, where rapidly changing conditions can catch drivers off guard. Further north, the situation intensifies across areas including Prince George and the surrounding districts, where steady snowfall develops through the day and peaks during the evening commute. Northeasterly winds enhance the impact, creating localized whiteout conditions that make travel not only difficult but potentially dangerous. In northeastern British Columbia, particularly in the Peace River region, snowfall totals increase further, reaching up to 25 centimeters in some areas. Here, the influence of colder air becomes more apparent, with wind chills dropping into the minus 25 to minus 30 range. This marks a transition zone between the more temperate Pacific-influenced air to the west and the deeply entrenched Arctic air mass dominating central Canada. Mountain regions, including major passes such as Rogers Pass, are also under significant stress from this system. Heavy snowfall combined with shifting precipitation types and fluctuating temperatures introduces the risk of rapidly deteriorating road conditions, as well as potential closures. The terrain amplifies the effects of the storm, making these areas particularly vulnerable. Crossing into Alberta, the weather pattern splits into two distinct regimes. In the mountainous regions, including Banff and Jasper National Parks, the system delivers prolonged snowfall, with totals potentially exceeding 30 centimeters. This sustained accumulation over multiple days increases the risk of hazardous travel conditions, particularly on mountain highways where visibility and traction are already challenging. Meanwhile, in the far northeastern parts of the province, a completely different hazard emerges. Here, the dominant feature is extreme cold, with wind chills approaching minus 40. At these levels, the risk of frostbite becomes significant within minutes, emphasizing the severity of the Arctic air mass in place. This stark contrast within a single province highlights the complexity of the broader weather system. Moving further east into Manitoba, the cold intensifies even more, particularly in the northern regions where wind chills between minus 45 and minus 50 are being reported. These are not just uncomfortable conditions, they are life-threatening. Exposure to such temperatures without adequate protection can result in rapid heat loss and serious health risks. This extreme cold is a direct result of the Arctic air mass being funneled southward and interacting with the broader storm system, reinforcing the idea that this is a multi-layered event with both dynamic and thermodynamic components. In Quebec, the situation becomes more transitional, particularly in the Abitibi-Témiscamingue region, where a snow squall watch is in effect. Unlike widespread snowfall events, snow squalls are highly localized, but can be extremely intense, producing sudden bursts of heavy snow and drastically reduced visibility. The atmospheric setup suggests that as colder air flows over relatively warmer surfaces, instability will develop, leading to these rapid onset conditions. This creates a different kind of hazard, one that is less predictable in exact location, but equally dangerous for transportation. The most severe and impactful conditions, however, are unfolding in Newfoundland, where the storm reaches its peak intensity. The Avalon Peninsula, including St. John's, is experiencing a full winter storm scenario with heavy snowfall, strong winds, and rapidly changing precipitation types. Snowfall rates exceeding 5 centimeters per hour indicate intense banding within the storm, which can quickly overwhelm road clearing efforts and make travel nearly impossible. The presence of warmer air aloft introduces periods of ice pellets and freezing rain, adding another layer of hazard before temperatures drop again and precipitation returns to snow. As winds strengthen and shift, blowing snow becomes a major concern, leading to near-zero visibility and true blizzard-like conditions in some areas. Central and northeastern Newfoundland are also heavily impacted, with widespread snowfall and strong winds combining to create hazardous conditions over a prolonged period. Coastal regions face additional challenges from very strong wind gusts, which can exacerbate the impact of the storm by increasing drifting and reducing visibility even further. The duration of the event, expected to last around 36 hours in some areas, adds to its severity, as prolonged exposure to such conditions strains infrastructure and emergency response capabilities. Looking ahead, the system is expected to gradually weaken as it moves eastward, but not before continuing to impact multiple regions through Wednesday. Improvement will begin in British Columbia as the low exits, while Alberta's mountain snowfall will persist into Thursday. The extreme cold in northern regions will slowly moderate, and conditions in Newfoundland will improve after a second period of deterioration. Overall, this storm represents a classic example of a large-scale Canadian weather system, where a single low-pressure system interacts with diverse regional climates to produce a wide spectrum of hazardous conditions.